In this lecture, we are going to write our own recursive function to convert any given decimal number to its binary form. So let's get started. So first of all, let's assume that I would like to convert a decimal number n, which is here equivalent to 4, to its binary form. So how do I convert 4 into its binary form? Because I would like to convert 4 into binary, so I'll have to divide 4 by 2, because by dividing by 2, I'm guaranteed that the remainders are either 0 or 1. So first I divide 4 by 2, right? So 4 divided by 2, the quotient is 2 and the remainder is 0. Then I divide this quotient 2 by 2, and now the remainder is 0 and the quotient is 1. Similarly, 2 times 0 is 0 and the remainder is 1. Okay, so this is how you do the process. Now you finally stop this here because now the quotient has become 0. So initially, step number 1, I start dividing 4, that is my input number 4, by 2, and then I'll find the quotient q and the remainder r. Here the quotient is 2 and the remainder is 0, right? Now 0 is the number that I need to print at the very last. So this is the last number to be printed. This 0 is the last number to be printed because I'll have to catch hold of all these reminders from bottom to top. This 1 is the first number that is to be printed, and this 0 is the last number that is to be printed. So the binary of this number 4 is 1, 0, 0. So I'll have to catch hold from bottom to top. So the first reminder that I get should be the last value to be printed. So this is the last value that needs to be printed, this 0. Okay. Now in the next step, what I do is, now the quotient becomes the new n, right? So I'll have to divide 2. This is the new n by 2. Now the remainder is 0 and the quotient is 1. Okay. So this is the second value of the remainder. Okay. And then now I'll catch hold of this quotient and make this as my dividend. So this 1 is my dividend. I divide this by 2. So every time I'm dividing by 2. Okay. Now here I get 0 as the quotient and 1 as the remainder. So this is the final step. This is the last remainder that I get. Okay. Now what I do is, here my quotient is 0, because as my quotient is 0, I'll have to stop my process here and I'll have to catch hold of the reminders from bottom to top, right? Or I need to first of all display this as my reminder first. This becomes the first reminder to be printed. This becomes my second reminder to be printed, and this becomes my third or the last reminder to be printed. Okay. So what I'm doing here is I'm actually delaying the printing of this reminder. I'm making a delay here, right? I'm making the delay here in printing the remainder. Okay. I'm making a delay in printing the remainder. So what I'm doing here is I'm actually dividing n by 2, getting the quotient and the remainder. I'm repeating this process for 3 times here, but I don't want to do this using a loop. I'd like to do this using a recursive function. So if I have to write a function, let's assume that the name of the function is, let's say, decimal d to binary bin. Okay, decimal to binary. This is the function. What is the input that this function could possibly take? The input is the number that I would like to convert. So here the input is the integer number n, right? In this example, n is 4. So I'll assume that my input is the integer number n. Now let's assume that we are going to display the remainder in the function itself. So I'll make the return type as void. I am not returning any value back from this function. Okay. So first of all, whenever you are writing a recursive function, what you need to think is, first is what is the argument input and what is the output. This you have already decided. Okay. Now step number 2 is you will have to think of the base condition, right? What is the condition that will help you to stop this repetition, right? So in this case, I'm actually stopping whenever my quotient becomes 0. So if my number n becomes to be 0, I'll stop the recursion. So I'll write if n is equals to 0, I'll just return back the control to wherever this function was called. I'll just write return semicolon. Okay. Remember, this is allowed. Although I've given void return type here, I can just write the return statement here. Okay. This will just simply return the control back to the place where this function was called. Okay. So this is the base condition. Whenever n is 0, I'll just stop the recursion here. Okay. Else I'll have to write some code to actually find the remainder and display the remainder. Okay. So what I'm doing, if it is not the base case, is this example, like I divide n by 2, right? So I divide n by 2 and catch hold of the remainder. Let's say that I'm having one variable r to store my reminder. So I'll just write R, my reminder is nothing but n mod 2. I'm just finding this reminder here. Here the reminder is 0, right? Now what I do is I do not display the reminder as it is right now, because this is the last reminder to be displayed. So I'll keep this printing the reminder as a pending statement right now. I'll make a delay here, and before I print the reminder 0, I'll have to continue with the process of division. Now I'll have to divide the previous quotient by 2. So my new value of n becomes the previous quotient, right? So what I do is now I get the new value of n. So now I can call the same function decimal to binary for the next division, wherein my new value of n is the previous quotient, which is nothing but n by 2. N by 2 is my quotient. So n by 2 will give me 2. So 2 becomes my new n. So this process will keep on continuing this. So I'll delay the displaying the reminder, and I'll continue this process. This keeps on continuing until I reach the base condition, right? So and then only then I'll have to print the reminder. Okay. So I've already stored the reminder in the variable r. So I'll just write printf %d r. Okay. So this is delayed. This will be just displayed only after all the instances of decimal to binary conversion is called. Once this is done, and once this is done, it will print the reminder and trace back. So it will print 1 and trace back. So 1 is displayed first. It will print 0 and trace back. Okay. It will print 0 and trace back, or it will go back to the main function. Okay. So this is briefly how it works. Now we are going to understand in more details how this recursion actually works. Okay. Now, first of all, this is the function that we have already defined, decimal to binary. It takes one argument, integer argument. Okay. So these are the line numbers displayed here. There are 12 lines in this function. Okay. Now there are two cases. One is the base case. This entire thing is the base case. Okay. And this else part is the non-base. So the function based on the value of n will either go to the base case or to the non-base case. Okay. But finally it will end by going to the base case. So first of all, let's assume that the value of n is 4. So initially from the main function, I'll make a call to this function decimal to binary by passing n as 4. So this is the first call to this function decimal to binary. Okay. So whenever n becomes 4, this instance I have presented here. Okay. This is the instance decimal to binary where n is 4. Whenever n is 4, it will obviously go to the else part. So I have already written down the else part, that is line number 8, line number 9 and line number 10. So whenever n is 4, in this case n is 4, also represented here. Okay, whenever n is 4, what happens is, first of all, I'll have to find the remainder, n mod 2. So the remainder is 4 divided by 2, remainder is 0. So remainder is 0. Okay, and then what I do is I'll have to call this function decimal to binary passing n by 2. What is n by 2? 4 by 2 is 2. So n by 2 becomes 2. So at line number 9, it is actually calling to the same function. So there's a recursion happening here, decimal to binary, wherein the instance of n, the value of n here is 2. Okay, so it is going to call this function decimal to binary passing n as 2. So this is the next instance of decimal to binary. Now if you come to this instance decimal to binary with the argument 4, here this printing 0. Now finally I'll have to print the remainder. In this case the remainder is 0, right? So printing 0, this is delayed actually. This is delayed. This is not happening right now. Okay, before this happens, it is calling this function decimal to binary passing the value of n as 2. So this is actually pending. This line number 10 is pending right now. So this decimal to binary with argument 4 is not yet complete. So it has to come back to this, because finally all the functions has to be completely executed. This is not completely executed as of now. So because in line number 9 there is a call to decimal to binary passing the value of n as 2, it will go to this function, the blue one, the second one. In this case n is 2. N is 2, meaning this statement n equals to 0 is false. So it will go to the else part. So I have written down 8, 9 and 10. Now what would be the remainder in this case? Whenever I divide 2, because my n is 2, 2 by 2, the remainder is 0, right? So the remainder is 0. I write down here. And then I'll call decimal to binary by passing the value n by 2. What is n by 2? 2 by 2 is 1. So this is my n by 2. 2 by 2 is 1. Right? So n by 2 is 1. So here I pass 1 as the argument. So it is actually calling this function decimal to binary 1. Okay. Also here I am printing the value of r. So here r is 0. So here printing 0 happens, but this is not encountered yet. This is done. This is done, right? This is not yet encountered. So this will be executed after some time. So here it is making a call at line number 9, decimal to binary, passing the value of n as 1. So it will call to this instance wherein n is equals to 1. Okay. Again n equals to 1. So n equals to 0. 1 equals to 0 is false. It goes to the else part. So line number 8, 9, 10 is there. What is the remainder if I divide 1 by 2? The remainder is 1. Okay. The remainder is 1. Decimal to binary, I'll have to pass n by 2. What is 1 by 2? 1 by 2 is 0. So here 0. And these two are already executed. This is not yet executed, but here remainder would be printed later on. Here remainder is 1. Okay. So now what happens is this is left pending. This is not yet executed. So at line number 9, it is calling decimal to binary, passing the value of n as 0. Decimal to binary n 0. This is the instance of n equals to 0. So whenever n equals to 0, now it comes to the base case. In the base case, if n is 0, I'll just simply return the control back to the place where it was called. Now, who called this function decimal to binary? Decimal to binary 0 was called at line number 9 of decimal to binary 1. So it was called here. So the instance, the return would be like this. It will return back the control to where it was called. So return back to this place wherein decimal to binary 0 was called. That means line number 9 is now completely executed. Okay, it has got the response from where it was passed to. Okay, but if you see here, decimal to binary with n as 1 is not completely done because line number 10 is still pending. So now it goes and execute line number 10. So it will print 1 in the screen. So 1 is displayed in the screen. So let me display 1 here. Okay, so that means now line number 8 was already done, 9 was already done, 10 is also already done. So there is no other statement to be executed in this particular function instance. So it will reach to the closing brace. That means this function is completely done now. Once this function is completely done, it will return the control back to the place where this function was called. Now this function was called from line number 9 of decimal to binary n equals to 2. So the control will now go back to this place. Okay, so that means this line number 9 is done now. So now it will come to the statement printf 0, which was pending. So it will print 0 in the screen. So 0 is displayed in the screen. Okay, now because there is no other statement to be executed, it will encounter the closing brace. That means this is already done. Okay, so this function is done. That means now it will return the control back to the place where it was called. It was called here at line number 9 of decimal to binary n equals to 4. So the control will go back to the same place, line number 9 of decimal to binary n equals to 4. Okay, so now this is it, line number 8, line number 9 already done. So line number 10 was kept pending. So now the turn for line number 10 has come. So it will print 0 because this is printf 0. So 0 is displayed in the screen. Okay, and then it will encounter the closing brace. So this also is done. So this function is completely executed. Now it will give the control back to the function where it was called. So this was called by the decimal to binary 4 from the main function. So in the main function, the control is returned and then main function will keep on executing until it reaches the end of the statement. So finally, if you see, the output is 100, which is the correct output because the binary of 4 is 100. Okay, so I hope you have understood how decimal to binary really works. Because in this problem, I wanted to delay displaying the remainder. Therefore, I placed this function call, that is decimal to binary conversion, before displaying the remainder. Okay, so this will ensure that remainder is delayed printing. So this will ensure that displaying the remainder is delayed. So I hope you have understood how this actually works. It's very important for you to trace this function and create the instance of this function for all values of n. In this case, there are 4 instances of this function. One for n equals to 4, the next instance for n equals to 2, the next instance for n equals to 1, and the final instance for n equals to 0, which is my base condition. So here my recursion actually stops. Okay, so and after the recursion stops, the tracing back of the function happens, right? And then finally the answer 100 is displayed while displaying the reminders in the reverse order, right? So this is how it actually works. To understand how this recursion actually works, you'll have to understand one more thing that is called as the stack data structure. So recursion is internally processed by using this stack data structures. I'm not going to discuss the stack data structures in this lecture. It is out of scope, but I hope by doing a tracing like this, as I have demonstrated here, you should be able to understand how does recursion work. But to understand recursion in more details or in more depth, you will have to understand what is the stack data structure. Okay, so that's all in this lecture. Stay tuned.